Hi, I'm Bud Andrus, Director of Product Management. I work on the Oracle Autonomous Database Product Management team, and my primary responsibility from a product point of view is a feature called Oracle Analytic Views. And today, I'm going to talk about one of my favorite topics, how to simplify development of analytic applications using analytic views. So thanks for coming. You're going to love it. All right, there's my speaker slide. This slide says that we don't promise to deliver anything in this presentation, but don't worry about it. Everything that we're going to talk about here is released product, so you don't have to concern yourself with that. So let's dive in. All right, I like to begin this discussion with a question. So if you're an application developer, you always have to answer the question, how are you going to build your applications, right? So if you want to build an application, a custom application that has, interactive reports, charts, maybe some maps, if you want user-defined data selection, that is a lot of, more interactivity. If it has multiple dimensions, for example, this application is about fuel prices in Italy, right? So it varies by time, fuel price, the price component, things like that. And what if it has different levels of aggregation? For example, year, quarter, month, and a time hierarchy. And let's make it even harder and let your users define calculations, right? So you have to decide how you're going to build this. All the charts and the widgets and things like that on the screen, that's the easy part, right? There's other parts that are much harder. Now, if you want to pause your screen and follow that QR code, you can actually go right to this app and take a look for yourself now or later, right? So again, how would you build it? Well, everybody knows the challenge is the SQL, right? There's great development environments. I use Oracle Apex all the time, but you have to supply the SQL. That's the hard part. So if you're doing something simple, just aggregating data, that's easy, right? That's just, select some columns, group bys, maybe some joins, pretty easy. Maybe if you have some, minor interactivity, you just have to swap up some column names, right? So, that's not too bad. But think about the application that I just showed you. There's a lot more going on with that, including time series calculations. And if you're building this, it's your responsibility to provide the SQL. So if you just want, percent change year over year, you're now doing 3-pass SQL, right? So the innermost part, you're going to do some aggregation. And by the way, when you do that aggregation, make sure you expand that filter and go and get the prior year, even if it's not on the user screen. Then you have to do the time series calculations. So get out your, analytic window functions. And then a third pass perhaps for the percent changes and things like that. And with time series calculations, don't forget, make the data dense by doing partitioned outer joins, right? So if you're developing your own application, it's your problem to write the SQL. And that's just, quite frankly, really, really hard. So you might not even attempt it, and you might, instead use a packaged BI app instead. But I'm going to show you how we can make this really easy. Now, if you want to go into a deep dive on this topic, again, follow the QR code, and you'll arrive at a live SQL tutorial. And you can go through this entire subject on this slide in a live SQL tutorial. It's really great. You'll love it. All right. So this is about analytic views. And the way I'd like you to think about analytic views is they're a feature in the database that provides you with a great foundation for your BI applications. So it's an in-database semantic layer that adds meaning to your data, and it simplifies your application development. So you might have a pile of tables, and if you try to query those pile of tables, you got to figure out what they are, how they relate to each other, how to present it to the user, and then, of course, how to generate queries against it, right? That's not a lot of fun. An analytic view will include everything you need to map to the physical layers. So maybe local tables or external tables over object stores, different styles of schemas, stars, snowflakes, denormalized facts, things like that. You're going to layer analytic views over all of this. And your applications aren't going to see the tables, they're going to see the analytic views. So you have one easy to query object instead of a whole pile of things. These analytic views are going to explain exactly what the data is. So it's not going to be a collection of columns over a collection of tables. Instead, you're going to look at it and you're going to say, this is sales by time, customer, supplier, and product. And maybe there's a hierarchy, or maybe there's multiple hierarchies. It's going to explain all of that to you. And it's going to have all of the calculation rules embedded into it. So it's not your problem to figure out how to aggregate or calculate certain types of measures. The analytic view is going to do that for you. And if you have multiple users querying this data with multiple applications, because all the calculation rules are embedded in the analytic view, everybody's going to get the same answer. So that whole nightmare of different users interpreting the data differently, getting different numbers and all that other kind of stuff, problem solved. So, it's just a great foundation. So first of all, if you have Oracle, any edition, you have analytic views. They're a feature of every edition of the Oracle database. They're there, they're no extra cost, just use them. So they have a couple jobs. One is this semantic layer, right? So as part of that, it defines all the relationships to the storage layer. It maps to the tables, it defines joins, it does all that kind of stuff. It has its own built-in constraints. Next, it defines a business model. It organizes the data in the way that you want users to understand, use, and calculate the data. And finally, it has a presentation layer. So you don't have to present users with column names, table names, things like that. All of the niceties that you want built in to display things in a clear, understandable, and pleasant manner to your end users is all built into this. So one collection of objects layered over your tables is just a complete package. Now for query, you actually have a choice. It has a dual hierarchical and relational representation. And what I mean by that is that if you want to query the analytic view as a hierarchical object with hierarchical semantics, there's a view that presents the data in that way. If you want to query it with group by style semantics, then you can do that also. So it's your choice. I'm going to make a prediction, however, and that is that you are going to love the view that presents with hierarchical semantics, and you're going to see why coming up in a few minutes. So regardless of which view you choose, you're going to write relatively simple SQL, and I'm going to show you examples of that. And then it's the job of the analytic view to transform these relatively simple SQL statements into the queries that are actually used for execution. So you write simple SQL and the analytic view is your query generator. And this is really nice because it does all the hard work, A, so you don't have to, and B, it takes care of optimizing the SQL for best performance. So you write SQL that is, very simple. You don't worry about where the data is. You don't worry about the calculation rules. You don't worry about optimizing it. And the analytic view will generate the best SQL possible for that particular query for your instance of Oracle and your storage layer and, all that other good stuff. All right, so let's just kind of start diving into the details of this. So from a developer point of view, the SQL, in this example, by the way, is a hierarchical semantic SQL. You can see that hierarchies keyword right there in the middle of it. It uses, familiar select from, where, maybe order by, query construction, right? This is just SQL, and the analytic view is absolutely no different from that, right? You can see select from, where, order by. we have these really interesting hierarchical columns that the analytic view manufactures for you, automatically. So if we go top down, we have things like member name. These present sort of the pleasant, user-friendly representations of the data. We have sales, a measure out of the fact table, and a calculation, sales percent change year ago. We select from the analytic view. Then we have this hierarchies keyword. And we just list the hierarchies that we're interested in using in this query. Maybe this analytic view is defined with 20 hierarchies, and I want to view it by time, product, and geography. Well, just list those. These take the place of joins and group by, right? No joins and group by in this query. Isn't that nice? And then in the where clause, we're using a level name column, another hierarchical column. And I'm just asking for whatever level of summarization I'm looking for, and I'm letting the analytic view query it for me, using the SQL that it generates. And then the order by is using another column that's manufactured by the analytic view higher order, which gives a nested hierarchical order within hierarchies, right? So you get all this stuff for free. So this is why I say you're going to love it. You're probably going to use this version of it when you are defining your SQL for your own applications, right? But, this doesn't look too hard, right? Select from where, maybe order by. All right. So here's a different form of it, a little bit more complex. And this is select from using and add measures. Now, the add measures is really magical, right? So what the add measures does is it allows you to define calculations dynamically in your query. So calculations can be embedded in the analytic view, just select them, or you can define them in the query itself. And if you look at sort of the syntax of this, it's leveraging elements of the hierarchical model. So if we look at this, we say sales, PP prior period is the lag of sales over a hierarchy, right? Not a column, no partitioning clauses in there like table queries. It's really easy to generate. So this is just sort of a variation of this. And it's interesting because as a application developer, this sort of turns things on their head, right? So normally it's a disadvantage to have to generate your own queries. Here, because the construction is really pretty easy, very template-like, easy to spit out using, some PL SQL code. Because you have access to all that, you can generate your own measures, right? Now, if you're using a BI tool, you're not going to be able to do this, right? So you actually have an advantage as a custom application developer. All right, so let's talk about query optimization for a minute. So the idea here, again, is you as the application developer, you're going to write some pretty simple queries. We just saw a few examples of that. And you're going to query the analytic view. There's actually two objects involved here. There's an analytic view and a hierarchy. They work together, but most of the time you're just going to query the analytic view. And the analytic view is going to generate all of the SQL necessary for execution. Now, what's really great about this, aside from the fact that your SQL will be simple, is that the analytic view knows everything about your tables. So it knows the structure, it knows what type of tables they are, it knows whether they're on object store or local in the database. It knows if it's a star schema or not. It knows all of this stuff. And it has its own built-in constraints. For example, in a hierarchy, it knows that it can expect many-to-one relationships. With all of that, it can generate highly optimized SQL for your use case. And, in every version of the database, it's improved, tuned, takes advantage of new features in the database. So you just kind of pick up all that for free when you query the analytic view. And then, of course, finally, it accesses your data, right? So all this optimization coming for free is just a tremendous advantage for you. And there's more, okay? So not only do you generate simple SQL and it generates the hard SQL, it does join eliminations, it knows what SQL plans it's, looking to get out of the optimizer and write SQL to, target those. All the SQL is always single pass over the fact table. And then there's a feature called the materialized cache. And this is really the ability to access one or more aggregate tables. The analytic view will write directly to the aggregate table. So it doesn't have to go through the same query rewrite process as, say, a materialized view. So it's completely deterministic, therefore completely reliable. The parse time around it is minimal. All great stuff. And then it can also do things like join pushing to remote or external tables, right? Because it knows about Oracle Object Store and things like that. If you want to use this materialized cache, which pre-aggregated data can be a tremendous advantage, right? It's much better to do less work than a lot of work efficiently. So whenever you can do less work, do less work. And aggregate tables are a great way to do less work. You can define the materialized cache yourself if you like, but there is a auto-tune feature that will actually track your workload statistics and create aggregate caches for you. And these aggregate caches are very compact, very efficient. So they're smaller, they're easier and quicker to create than typical materialized views. And then a great thing is that they have the greatest impact on the most difficult queries. So these charts are from some real world performance tests. And on the left is before using materialized cache, and on the right is after. And the thing about query patterns is that the queries that tend to be most difficult and use the most CPU, take the longest period of time, are queries that tend to be high in hierarchies, because those queries tend to aggregate the most data out of the fact tables. And that's exactly where materialized caches usually live. So, a few materialized caches can do a tremendous amount of work optimizing the queries and reducing the overall CPU load on the system. So when you're using analytic views, be sure to check out that feature. All right, so sounds great. Can I do this? I don't know. Sounds hard, maybe, I don't know. Okay, first of all, you have another QR code to follow. So if you want to kind of dive into this in detail, go ahead and do that. You'll end up again at a live SQL tutorial. But let's kind of think about this a little bit, right? So here we have a sort of standard group by query. And think about the roles of these columns. So some columns, we can think about as attributes, right? They're in the select list and the group by. And others we think about as measures, right? So they have sums around them, right? And if you can understand this query, you can actually understand an analytic view quite easily, right? Because columns play the same roles, and the analytic view is going to let you organize and predefine all of these relationships up front. And that's all you really need to do. Now, next, sort of think about hierarchies, right? You kind of know this naturally. So you can think about year, quarter, month, right? So a month is a child of a quarter, is a child of a year, right? When you write a query like this, you just sort of do it without thinking about it. Well, if you just think about it, you're going to organize these into hierarchies. All right, so how do you do that? You do that in an object called an attribute dimension. So the attribute dimension is going to be mapped to a table you're going to have a list of columns in the attributes, and then you're going to create levels. And a level such as month has a key value, has a member name value, which gives you the opportunity to provide a nice label for your month. So maybe your month ID is an integer. You don't want to display that to a user. Give them a nice name. And then we have hierarchies, determinants. And determinants is simply saying for every month, there is only one value of a quarter, right? So this is a constraint. And this repeats a couple times, right? This is the basic construction of an attribute dimension. Not hard at all. And then we have the hierarchy itself. The hierarchy is actually a view, so it's an object that you can query. And all this does is organize these levels from that attribute dimension into parent-child relationships and creates the actual view that you can query. The idea here is that all of the metadata, or most of the metadata, is in the attribute dimension and it can be reused over many hierarchies. So those are complete examples. They're, again, they're not very hard. And then finally, we have the analytic view itself. So the analytic view is where it all comes together. So we're going to create an analytic view using a fact table. This is where the fact data comes in. We're going to list the dimensions and the hierarchies that we want to use. And then we have this key references. That's your join. Then we have a list of measures. In this example, the fact measures are coming from the fact table, and sales prior period is a calculated measure. So that's a definition of a complete analytic view. All right, so that's kind of it in a nutshell. If you want to, again, take a look at this for yourself, you can go to this application and run it live. This application is up 24/7. You're welcome to look at it anytime you want. Just follow the QR code. And again, I'm going to point out a few things here. One, there's a lot of interactivity. So the user has the ability to select time periods, different levels of time across the hierarchy. They can choose in this case, a fuel type and a component of the price. You'll see what that is when you get there. They can choose various transformations. So, you can look at the actual value, prior period, change prior period, things like that. And then you can smooth it, right? With this data, it might be nice to do moving averages and things like that. And every visualization in this report has the ability to show the SQL. So, up towards the top, there's a show SQL switch. Just turn that on, and you can see exactly what this application is doing. And what you're going to find is that all the SQL for all the different reports is pretty much the same thing. And the way this application is built is there's a single PL SQL function that generates the SQL for every one of the reports and graphs in this application. So I think you're going to have a lot of fun if you actually go to that and check it out, poke it, prod it, look at the SQL, and it's going to be very informative. All right, so thanks for listening. I hope you found this informative. If you want to know more about analytic views, hit that QR code there, and you're going to go to my entire collateral library for analytic views, and you're going to become an expert. All right, thanks a lot.